Dear viewers, welcome back to my channel. Today we can have a look to 8085 microprocessors. What is the difference between microprocessor and a microcontroller? In a microcontroller, CPU, RAM, ROM, input or output, timer, serial common port, everything is incorporated as a single unit. But in microprocessors, RAM, ROM, input or output port, timer, serial common port, CPU, everything are different units, and data and address from each unit is transferred to other unit by means of address bus or data bus. This is the main difference between microprocessor and microcontroller. Then processing power is high in microprocessor, processing power is low in microcontroller, power consumption is high in microprocessor, power consumption is low in microcontroller. Microprocessors are typically 32 or 64 bit, microcontroller 8 or 16 bit. Coming to application, microprocessors are designed for general purpose, example our laptops and desktops. Microcontroller is designed for a single purpose, example washing machine. That is, the output will be designed for particular inputs. It is microprocessor is less reliable, microcontroller is highly reliable. 8086, 8085, these are some examples of microprocessors. 8051 is an example of microcontroller. Then the evolution of microprocessors, we can say there are different steps of evolution: first generation, second generation, third generation, fourth generation and fifth generation. And nowadays we are using fifth generation microprocessors, especially Pentium processors by Intel. Then second generation, and the 8085 processor which we are discussing today is a second generation processor. Then first generation processor. The first microprocessor was developed by Intel in 1971, that is Intel 4004, and from 1971 to 73 the processors developed are considered as first generation processors. They are mainly of 4-bit processors with 16 pins. Then came 8-bit and 16-bit with 40 pins. Then second generation processors. Second generation processors includes, it is offering high speed and density than that of first generation with NMOS technology. PMOS technology was used in first generation microprocessors. Then ability to address large memory spaces, ability to address more input or output ports, faster operation, better interrupt handling capacity are other different features of second generation microprocessors. Then came the third generation microprocessor with high speed and very strong processing capability compared to second generation microprocessors, and it is easier to program also, allow for dynamically relocatable programs. Then fourth generation microprocessor, they are mainly of 32-bit processors, supports increased number of addressing modes also. Then came the fifth generation, and the Pentium by Intel is main among the fifth generation microprocessors. It consists of 32-bit processor with 64-bit data bus and available in wide range of clock speeds and from 60 MHz to 3.2 GHz. Processing speed increased tremendously. Pentium executes 2 instructions in 1 clock speed. Then a microprocessor with 1 GHz clock can execute 2000 million instructions per second. And now the Pentium, Celeron and very recently dual and quad core processors working up to 3.5 GHz speeds is the last stages of evolution. And Pentium was followed by Pentium Pro CPU, and later an extension to it was made and named as Pentium 2. Then these are all about the evolution of microprocessors. Then about 8085 microprocessor. It is a second generation microprocessor, and other key feature is it is 8-bit processor with 64K memory. NMOS technology is used here with 40 pin. This 8085 microprocessor is a 40 pin device. It has multiplexed address and data bus. It works on 5 volt DC power supply. Clock frequency is 3 MHz while minimum frequency is 500 kHz, and it is provided with 74 instructions and 5 different addressing modes. Then it is 6 registers B, C, D, E, H and L, and accumulator is of 8-bit accumulator. These are the key features of 8085 microprocessor. Then coming to bus bus architecture of 8085 microprocessors. The 8-bit 8085 communicates with the other units using 16-bit address bus, 8-bit data bus and a control bus. We already told that in a microprocessor, each units will be different. Memory unit, input unit, output unit, everything will be different units. The data from input to memory, from memory to output, everything is transferred by means of 3 buses, that is address bus, data bus and control bus. As indicated in the arrow, address bus is a unidirectional bus, data bus is a bidirectional bus and control bus it is unidirectional bus. And address bus it is 16 address lines, comprises of 16 address lines A0 to A15, and data bus consists of 8 data lines D0 to D7 lines carrying data which is in bidirectional mode and sent data from microprocessor to peripheral and from peripheral devices to microprocessor. And control bus it is a single line to carry the synchronization signals. Then coming to the block diagram of 8085, we can see here that this is the there are 4 main parts: a processing unit, storage and interface unit, instruction unit, interrupt and serial input or output unit. These are the 5 main units of 8085. First is processing unit. This accumulator, temporary register, flags and ALU. These 4 components are the main part of processing unit. This is arithmetical logical unit where arithmetic and logical operation takes place according to the instruction. And the output obtained is indicated by proper flags here. Then the temporary register stores that temporary data and accumulator stores the output of the or result of the operation. It is stored by accumulator. Again, the other unit, second unit is storage and interface unit, which consists of general purpose registers, that is B, C, D, E, H and L, stack pointer, program counter, decrement and incremental last, and address buffer and data buffer. Okay, this includes the storage and interface unit. This unit is called the storage and interface unit. This is processing unit. This is storage and interface unit. Then is instruction unit, which consists of instruction register, instruction decoder and machine cycle encoding and timing and control signals. Control signals, status signal, DMA signals and reset signals are the main signals associated with the timing and control. And then also other unit called interrupt control, which is capable of stopping the execution of main program temporarily and can execute the branch options. Okay, then RST 5.5, RST 6.5, RST 7.5 trap are the important pins associated with interrupt control, and interrupt and serial input output control is the other unit. So the 4 units: processing unit, which comprises of arithmetic logic unit, flags, temporary register and accumulator. Then instruction unit consists of instruction register, decoder and timing and control. Then storage and interface unit consisting of general purpose registers, stack pointer, program counter, address bus and data bus. Then interrupt and serial input and output unit. So these are the main units of 8085 microprocessor. And dear friends, we will be going deep into 80 microprocessor about its architecture, its instructions, its timing diagram, everything in the coming videos. So thank you.